Forget dusty labs, robots are everywhere. From factories to hospitals, these metallic marvels are changing the world. And among them, robotic arms? Well, they're not just mimicking humans, they're outperforming us. But what makes these arms move with such precision and power? The answer lies in a hidden hero, the actuator. It's the brain and brawn behind every robotic twist and turn. An actuator is a combination of a harmonic gear, a BLDC motor, and an advanced control board equipped with a magnetic encoder. Let's crack open this marvel and see how it ticks. This part is the harmonic gear of the actuator. Other two similar gears used in large machines are cyclodal gear and planetary gear. The reason why we use harmonic gear here is that it has a relatively higher output torque and is ideal for machines using robotic arms. Harmonic gears are so important in robotic arm applications, and they consist mainly of three parts, namely the circular spline, the flex spline, and the wave generator. The wave generator produces a wave-like motion that deforms the flex spline, causing it to engage with the teeth of the circular spline. On the other side is the board, which has a magnetic sensor that efficiently detects rotations. Real-time monitoring of magnetic field changes is possible with this sensor. It enables instant adjustments for precise and controlled movements. Now, the BLDC motor. It helps to enhance the force and accuracy of control. Its stator, rotor, and magnets work together to generate smooth and flexible movements. The precise winding of copper coils and magnet alignment showcase skilled craftsmanship in creating these sophisticated actuators.